Hello and good morning. Before we continue Biostatistics Basics Series 5, I would like you to keep in mind what do we mean by standard deviation and variance. Before we start talking about comparison of means, I want you to understand standard deviation and variance. For those of you who would like to read by yourself, I would provide you the link. It's from mathsisfun.com. And here in these examples, I am going to explain what is variance and standard deviation using an example in which we find mean heights in different dog breeds. Now, if you look at this picture, you would see on the left-hand side on the y-axis of the picture, the scale in millimeters is given. The height of the dog is measured in millimeters, and the green line denotes mean height. So all of you know how to calculate mean, and we have a population of 5 dogs here, and we measure the height from the floor, and we get a mean of this population of dogs as 394. So on the second picture, you can look at the green line, which denotes the mean of the population of dogs height. So we get 394 millimeters. Now you would see these small red arrows which denote individual dog's height. These are the red arrows at the backs near the root of the neck. This means their height is measured from this marker, and when you try to plot a distance between this green line and these markers, that is the red markers at the root of the neck of the dogs, um, you would see there is some distance which is measured in mm. The first dog measures the distance between the mean, that is the green line, and the height of the first dog is 206 mm. The next dog we have a distance of 76 mm, and in the third dog we have a negative distance of 224 mm. Similarly, we have got a distance of 36 mm from the mean, and in the fifth dog we have minus 94 mm from the mean. So in short, we have right now measured distance of each of the dog's height from the mean height of the dogs. Now on the right hand side of this slide, you would see a table which gives you mean and the data from the 5 dogs, that is our population of 5 dogs. And we have calculated a distance from mean by subtracting data obtained from the each dog, that is the height obtained from the each dog from the mean. So we have got some negative results, we have got some positive results. When 394, we subtract 600 from 394, we get minus 206. Now, distance from the mean is usually denoted in terms of squared distances. The reason behind squaring the distances is we eliminate the negative signs in front of the distance from the mean. That is 206. If we square it, it becomes a positive number. That is 42,436. So we calculate variance. Now, in all the books of statistics and in the maths textbook, the distance from the mean is given in form of variance, which is squared actual distance from the mean. So we have got variance formula, and I will show you the formula, and below is the calculation of variance. So we get 21,704. Now we add up all these squared distances from the mean and we divide it by the population, that is 5 dogs. Now we calculate standard deviation from the formula given below. Sigma equals to root of 1 upon n, and sigma where we start with data 1 and continue till data 5, that is represented by n, into the distance minus the mean, the whole square. So we know from the previous classes that standard deviation is defined as square root of variance. So we have already calculated variance and we would calculate standard deviation. So we get 147. Now here below the sigma, just to refresh your mathematics, I is the first number in the series and n denotes the total data or the number of subjects in the population. That is the 5 dogs we are discussing here. And we calculate the spread of the data in terms of standard deviation, and we compute variance to know the distance from the mean. Now how it is important to us? We can use standard deviation to classify uh, the height of the dogs. So we would like to use this data, which is obtained from the 5 dogs, to compare with a height of a different dog. And we would like to classify whether the dog is short or tall. So here we talk about the first use of standard deviation, and it is represented by these blue lines. On the left hand side of the picture, on the left hand side you will see a picture with two lines, that is one line above the mean and one line below the mean. So this denotes standard deviation, plus one standard deviation, which is on the top of the green line. The blue line, which is below the green line, is minus one standard deviation. Now here we have a population of 5 dogs. That means we have used formula for population standard deviation. We have utilized the first formula, and if you have a population of some 1,000 subjects and you need to require to pick up a sample of at least 500 or 200 or 100, then you would utilize the second formula, that is for sample standard deviation. Now I would explain you how you can classify the height of the dog into a short dog or a tall dog when you are given height of different dogs. Now, any dog whose height falls above first standard deviation or one standard deviation, as given in the pic, would be classified as tall. That is one standard deviation towards the higher side from the mean. If the different data is given to you, which has height of different dog, and you want to classify it as tall or short, you compare that dog's height, whether it falls in the first standard deviation, that is on the higher side, or it falls beyond the first standard deviation, that is above 600 mm. So if it falls beyond the blue line or 600 mm towards the higher side, that is one standard deviation towards the higher side, you will classify the dog's height as tall. Now if suppose you have got a dog's height of 110 mm, that is the height of the dog from the floor, 110 mm, this number falls below the blue line in the negative standard deviation. That is, it is quite below the blue line, which is somewhere at the level of 200 mm, and you will classify this dog as short. Now similarly, this analogy can be utilized for comparing different data, and it can be utilized to calculate IQ or classify IQ or growth rates based on standard deviations. Now here in this slide, I show you a graph which denotes IQ calculations according to different tests. This data has been taken from iqcomparisonsite.com, and here if you look at these left hand side standard deviation, that is 40 to 69, which is extremely low, so it falls beyond two standard deviations. Okay, when you see this central line as 0, +1 and -1 standard deviation is usually considered as average intelligence. or +1 or -1 is usually considered normal. Now, if you proceed towards the right hand side and you see the second standard deviation, that is 70 to 84, we have IQ of below average. Now, if you move towards +1 and -1 standard deviation, from that is from 85 to 115, the IQ is considered as average. Now, if you move towards right hand side beyond +1 standard deviation towards 2 standard deviation, that is, it is denoted by 116 to 130, we classify IQ as above average. Now, if you move beyond 130 to 160, we have very superior IQ, and that's way beyond average or above average. And that's how we classify IQ, and we classify whether the dog's height is shorter or taller than the data given in the previous slides. Thank you.